Hello, today we are going to be talking about solving quadratic equations by factoring. Alright, so the steps are to solve for 0, factor, use the zero product property, set each factor equal to 0 and solve, and then you can check if you want using your calculator. So the first thing is for number 1, we are already solved for 0 because it says equals 0. We are already factored because this is represented by factor times factor. So now we just have to do the zero product property. So the zero product property states, so ZPP, states that if A times B equals 0, then either the first factor, A, so we can even put that in parentheses, could equal 0, or the second factor, B, could be equal to 0. So I have two factors here. I have x plus 5, that's factor number 1, and then we have x minus 2 as factor number 2. So x plus 5 could be equal to 0, or x minus 2 could be equal to 0, because 0 times any number is 0, and any number times 0 is equal to 0. So I can start by solving, and this is going to be negative 5. That's our first solution. And our second solution will be x equals 2. All right. So you can check by plugging in or using your graphing calculator. So negative 5 plus 5 is 0 times negative 7 is still 0. And then 2 minus 2 is 0 times positive 7 is still 0. So let's take a look at the next example. Step 1, solve for 0, done. Step 2, factor. If you would like right now to go back, I think the iCard is going to pop up. You can check how to identify factors in the graphing calculator. You can take a look at that video now. And then after this, I'm also going to post the video of how to factor trinomials. That should also be in the iCard right after that. So the first thing I'm going to do is identify the sum, which is a positive 3, the product that is negative 18. And you want to identify all of the numbers that multiply to negative 18. So that's 1 and negative 18, 2 and negative 9, 3 and negative 6, 6 and negative 3, 9 and negative 2, 18 and negative 1. So which two numbers help you make a positive 3? That's going to be 6 and negative 3. So set up your two factors. It's still set equal to 0. That's very important. And now we place in our factors, x plus 6 and x minus 3. Now we have our factored form, so we're going to work on the zero product property, which is the exact same as we did in number 1. So our first factor of x plus 6 could equal 0, or our second factor of x minus 3 could equal 0. Now I'm going to solve by subtracting 6 on both sides, and I will also solve by adding 3 to both sides. These are our two solutions. So if you'd like to practice with number 3, by all means. So once again, our sum is positive 7 and our product is positive 10. Our factors are 1 and 10, 2 and 5. 2 and 5 will help us make 7. So I set up two factors. Now we're going to use the zero product property. Each factor could be 0, so we'll set them both equal to it. Solve. And these are our two solutions. If we take a look at example number 4, you'll notice we have to do the first step, which is solve for 0. So, solving the right side for 0 is going to be the easiest since I only have this negative 2, and I can get rid of it by doing the inverse, which is adding 2. So now I'll have x squared minus 10x plus 24 equals 0, and now I use the same process. So two numbers that multiply to 24 that also add to a negative 10 are going to be 6 and 4, but they both have to be negative. Okay, once again, if you needed to go through the full process of factoring, by all means, I'm just going to speed through this a little bit faster so that the video is not too long. So each factor could be set equal to 0. Add 6 to both sides. Add 4 to both sides. and those are our solutions. All right, if you'd like to try number 5 and 6 on your own, by all means, pause the video. All right, so I have to subtract 3x from both sides in order to solve for 0 on the right side. So this is going to get me x squared plus 2x minus 35. Two numbers that multiply to a negative 35 but also add to a positive 2 are going to be positive 7 and negative 5. I'm going to set each factor equal to 0. Subtract 7 from both sides. And add 5 to both sides. If we take a look at number 6, I once again have to add 7 to both sides, but I cannot combine 14x and 7 because they are not like terms. So I have to attach it to the end of my polynomial, and the right side is still 0. So this one's interesting because I cannot go straight into sum and product, but I do have a GCF, so I can actually factor out the GCF into the front, but then realize that 7 times this factor is going to equal 0. So this 7 can actually be inversed by dividing by 7. I'll be left with x squared minus 2x plus 1. And 0 divided by 7 is still 0. Because this 7 is not going to impact my solution, so I can divide it to get rid of it, because 7 divided by 7 is 1. So now I have to continue by factoring two numbers that are going to multiply together to get 1, but also add to a negative 2 is negative 1 and 1. Now I set each piece equal to 0, but you'll notice the factors are the same. So when I add to both sides, I'm obviously doing the same exact thing twice. That's because we actually only have one solution. X equals 1 is our solution, since it showed up twice. All right, I hope you enjoyed. Thanks for watching A. Heisek Creation. Bye-bye.